the semiconductor rules. So let's begin from this title itself. What are these conductors? You know, what are these conductors? So, conductors are materials that allow electricity or heat to pass through them. Why are they able to conduct electricity through them? It is because of the presence of free electrons that these conductors are able to pass heat or electricity through them. For example, any metals like steel or aluminum can be called as conductors. Next, what do you mean by insulators? Insulators. Can you describe insulators? So, insulators are materials that do not allow heat or electricity to pass through them because they don't have free electrons. Free electrons are tightly bound in these insulators. Example for insulators can be glass or rubber or anything like that. So there also exist some materials like germanium, silicon or carbon that whose conductivity and resistivity lie in between these conductors and insulators. Such materials are called as semiconductors. Okay, semiconductors. Now the semiconductors are having many applications in our daily life, and it is widely used in this electronic circuits. So, semiconductors are like those switches. What is the property of the switch? What is its property? Switch. It will allow electricity to pass through them based on our wish, as and when required for ourselves. Like that, semiconductors are also act. So, earlier I described semiconductors as materials that whose properties that lie in between these conductors and insulators. But now these semiconductors are being described as chips or integrated circuits. Actually, this story of the semiconductor begins from the 19th century. That is from the 1947 at the Bell Labs. In the Bell Labs, three scientists, namely John Faraday, William Shockley and Walter Brattain, they conducted experiments and discovered this transistors. So these three discovered transistors, and at that time this discovery was something considered very big, and they even got Nobel Prize for this discovery of transistors. So then before transistors were introduced or discovered, our electronic devices greatly depended upon this vacuum tubes. So, the problem with this vacuum tube was that these vacuum tubes used to consume more power compared to resistors. They need huge amount of power for their working. But these transistors, on the other hand, used to consume only very little power, which is very good now, consuming little power. These transistors are only a family of the semiconductors. There are many other appliances or devices that comes under this category of semiconductors. So, this resistivity range of the semiconductor lies in between conductors and insulators. That is 10 raised to -4 to 0.5 ohm meter. So, just note some things. I'll be asking some few questions at the end. You could just note the resistivity of the semiconductor lies in between 10 raised to -4 to 0.5 ohm meter. Now, the semiconductor. Now, I described earlier as semiconductors are neither good conductors nor good insulators. So, their properties lies in between these conductors and insulators, and can only conduct only at certain temperatures. So, these if we are not able to classify these semiconductors neither under conductors nor under insulators, why can't we call it as resistance materials? So, the answer to this question can be given by taking some of the resistivities of some materials. Like now I am taking some of the resistivities of some materials. First one is copper. Copper is having a resistivity of 1.7 into 10 raised to minus 8 ohm meter. Now this copper is a good conductor. And next one is germanium. Germanium is a semiconductor. It's having a resistivity of 0.6 ohm meter. Next is glass. Glass is having a resistivity of 9 into 10 raised to 11 ohm meter. This glass is an insulator. And the last one is nichrome. Nichrome is having a resistivity of 10 raised to minus 4 ohm meter. So this, now compare these resistivities with each other. This is our semiconductor. Now compare the resistivity of this semiconductor germanium with copper. Copper is having a resistivity of 1.7 into 10 raised to minus 8 ohm meter. It is a very small number compared to resistivity of this germanium. So, compared to copper, copper or conductor, this resistivity of germanium is higher. And compared to insulator or glass, the resistivity of this germanium or semiconductor is lower. So, now we understood that semiconductors, the resistivity of the semiconductor lies in between the conductors and insulators. And now our question was why we are not considering the semiconductor under a resistance material. This is a resistance material. Why we are not considering these semiconductors under a resistance material? So for that also, just check these resistivities. Now nichrome, even though it is the highest resistance material, it is having a resistivity of 10 raised to minus 4 ohm meter. This is again a small number compared to this germanium. So by simply taking this example of this highest resistance material, we understood that we can't make germanium or classify germanium under this resistance material. Okay. Now, it is all this time I was talking about only resistivity for the semiconductors. But one thing that you all have to notice, it is not only the resistivity of the material that decides whether a substance is semiconductor or not. There are many other properties that decides whether a substance is semiconductor or not. So, next is properties of semiconductors. There are three major properties that I am going to discuss. First, one is related to the resistivity of the material. So, it can simply be said from these itself. That is, we are talking about this germanium or semiconductor. So, the resistivity of the semiconductors are like less than insulator, and it is more than conductor, which we said before. This is the first property. that is resistivity of semiconductor is less than insulator but more than conductor. This is the first property. So next property is related to resistivity. Next property is related to temperature coefficient of resistance. So these semiconductors are having negative temperature coefficient of resistance. This means that the resistance of the semiconductor decreases with increase in temperature, or the resistance of the semiconductor increases with decrease in temperature. For example, in this case we have the example of germanium. This germanium acts as insulator at low temperature. That means if I am keeping this germanium at a very low temperature, it can't conduct electricity, or it acts as insulator. And at high temperature, it acts as conductor. So this is the second property of semiconductors. Now the third property is very important property that we will be discussing all through this chapter. That if I am taking some semiconductors and I am adding some sort of metallic impurities into that semiconductors. So what happens? This metallic impurity can be like this arsenic or gallium or anything like that. And if I am adding these things into the semiconductor, its current conductive property changes. That is, when a suitable metallic impurity like arsenic or gallium is added to semiconductors, its current conductive property changes. So this is the third property, and it is a very important property. Next we discuss about the bonds of semiconductors. So what are these bonds? We were hearing this term from very many times. So what are these bonds? Bonds are something that keeps something together. Bonds are something that keeps the atoms of the elements together, or which helps them held together. So it is due to the bonding action of valence electron that makes the atoms together. So why are these atoms participating in this bonding? Everyone needs a stable configuration or stable state. So to attain that stable state, these atoms are participating in bonding. These atoms participate in bonding either by using their electrons or by gaining some electrons or sharing electrons. That we all know. So in the case of semiconductors, this bonding is formed by sharing of valence electrons. It is through sharing their electrons that they participate in bonding. So the bond formed by the sharing of valence electrons is called as covalent bonding. So they are having covalent bonding with each other. So now let's discuss the covalent bonding among germanium atoms. Covalent bonding germanium. So this germanium is having a valency of 4. It's having 4 valence electrons. So let's this is the germanium atom. This is again we have 3 germanium atoms. also having 4 electrons. All these 4 will be having 4 electrons each. Now this central atom will also be having 4 electrons. Now just see this central atom. It is through a business of sharing that this bonding diagram for this set. So there are 4 germanium atoms. This is the bonding diagram. Central atom is having 8 electrons. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. This is the bonding diagram. Now we usually call germanium as germanium crystal, right? So what are these crystals then? So crystals are substances in which atoms or molecules are having a well-defined structure or an orderly pattern. These substances in which atoms or molecules are arranged in orderly pattern. All these semiconductors are having a crystalline structure. All semiconductors have crystalline structure. So, first, let's talk about germanium crystal. Germanium was Germanium is an earth element and it was discovered in the year 1886 and it was recovered from the ash of coal or from the flue dust of zinc smelters, and this discovered germanium was in the form of germanium powder, and this powder was then transformed or purified into pure germanium, and it is having a valency of, as I mentioned before, it is having a valency of 4. It is having a valency of 4 and its atomic number is 32. This is its valency. Atomic number is 32, which means it has 32 electrons and 32 protons. So what do we call for elements having 4 valence electrons? We call some divalent, trivalent, yes, tetravalent. So this germanium is a tetravalent element. Next is silicon. Silicon is found in most of the common rocks and this sand found in beach, and it is silicon dioxide, and it is having an atomic number of what is its atomic number? 14. It means it has 14 electron and 14 proton. And these silicon atoms, like I drew before here, is covalent bonding among germanium atoms. Like that, silicon atoms are also held together by covalent bonding. So, next we can discuss about the energy band distribution of these atoms. Energy band distribution among the semiconductors, germanium and silicon. First, let's talk about germanium. This is energy. Energy is an electron. So, this is the energy gap of 0.7 electron volt. Next is silicon. This is the first band of silicon. This is the second band. This is valence band. This is conduction band. Here the energy gap is 1.1 electron volt. Look at these two energy gaps. It is very small, right? 1.1 electron volt and 0.7 electron volt. So even at room temperature, these materials or these germanium and silicon might attain these energy levels, and the electrons present in the valence band might reach or cross over to conduction band. So these semiconductors can also be described as substances which have almost filled valence band and empty conduction band. So after they gain this energy and reach to, after these electrons gain some energy like this energy and reach to conduction band, they'll be called as free electrons. The electrons that reach conduction band can be called as free electrons. Free electrons will be able to conduct. So now these energy band diagram is very useful for understanding the current flowing through semiconductors. So I'll ask some simple questions based on this what I have taken. And can you say what are conductors? Two types of conductors. Conductors are simple substances that allow heat or electricity to pass through. So, Talba, can you just give one example for a conductor? Yes. Nandana, what do you mean by insulators? Insulators conduct electrons. So, example for insulators, aluminum. One example. What is the forbidden energy gap of germanium? What is the forbidden energy gap? Forbidden energy gap of germanium is 0.7. So, what is the forbidden energy gap of silicon? 1.1 electron volt. Now, these semiconductors are held together by some bond, which is formed by the sharing of electrons. Such bonds are called so that was about my topic.